Hello everyone, welcome to my video. And in today's video, I'm going to show you how to design a vegan tube configuration file to be used with etracer. So this video clip will be the first of a series of video clips on this topic. So in this video clip, I'm going to show you the fundamental of the configuration files. Okay, so basically the tube configuration file is designed to it has two parts. The first part is to display the curves, the measurement on the screen in the plotting area, and it also contains a guide, the wiring guide for the user to hook up the connections to test the device, and it also contains a part related to the hardware, the desired voltage to send by the hardware, so that the measurement can be taken by the at that voltage level. So it has two parts. One part is not related to the hardware, and another part that's directly tied to the hardware. So the first part, the software part, has a configuration for setting up the plot. So basically it's this part: title, x axis, y left, y right, these parts. Okay, so this part is basically configure the range of the plot, and so the x-axis is always HV1, and HV1 is always used for the plate to supply the voltage to the plate. If it's the device under test contains only single unit, HV1 is always used. Okay, and so we can configure the display range for the for HV1, and the maximum is I think it's 800, but let's say we can change this setting. Let's say we only want to display up to 500. Okay, and in this graph, it can display two sets of curves. One set is refer to the left axis, and one set is refer to the right y axis. So the left hand side is the default side. You can turn it off to none, but usually we're going to use this. And this one can display the the current of the HV1, or the current of HV1 plus HV2. Okay, so etracer has two high voltage output, HV1 and HV2, and the way it's designed, HV1 is always a master and HV2 is a slave. So if we are testing a single unit, then we always use HV1. So if you don't know what's HV1 and HV2, you have to go back to the PCB menu, and you can find the hardware's architecture of etracer there. Okay, so if we are testing for example, a twin triad or a device that contains two identical units, we might want to turn on the right axis. So you can see the right axis is marked with green green color, and here we can adjust the maximum, the full scale of the reading. So for example, we can change the maximum value to be for the left y-axis to 5 milliamp, and we can change the maximum value of the right y-axis to 10 milliamp. Okay, so they can be totally independent, but usually we configure them to the same maximum value to be able to compare both currents. Okay, so this is the part to configure the way the measured data will be displayed in the plot, and you can put the title there. For example, if we're testing a 300B, we can put the title here, and you have to be noted that this part only controls the display. It has nothing to do with the actual voltage sent to the hardware. The voltage sent to the hardware is controlled by these 3 tabs. Okay, we'll leave the leakage test untouched for now because this is an experimental feature, and in the official etracer configuration file, the leakage test is not configured. So we have to the voltage sent to the hardware has to be input under each tabs, and the display part is not has nothing to do with the configuration that's sent to the hardware. So, but why we need to separate setting? It's because for quick scan and full scan and for corner cases, their display range can be different. So, by simply enter the range in the quick scan or full scan, because some configuration files it probably only configure 1 or 2 tabs. So it cannot the software cannot derive for the full range for the data to display. So that's why the graph the plot has the display range is configured separately here. So in today's video, we are not going to touch this the configuration for these tabs, and it will be we are going to cover this in the following video clips, and maybe 1 video clip for a specific type of tubes, for example, rectifier, triode, pentode. Okay, and we have to know that besides configuring the tabs here for quick scan, we need to put the reference value of the parameters here in the reference column. If it's there's 2 sections, we need to provide the reference for for both sections. Okay, so this is but we're going to talk about it when we go to the detail of configuration for each tabs. Okay, the second part that's not related to hardware is the this section. And this section we can input the name for each pin. For example, if the device under test is a 12X7, we can type in the name for each pin. Like for pin 1 is plate, and pin 2 is grid, and pin 3 is cassette, and so on and so forth. Okay, so this part is purely here to help the user to wire the connections. Okay, so here we know, okay, we can connect plate to the pin 1. Sorry, we connect HV1 to pin 1, which is a plate, and for grid we need to control it, connect it to the negative output of etracer, and the cassette goes to ground, and so on and so forth. For pin 4 is heater 1, pin 5 is heater 2, and pin 6, 7, 8 is the second section of the DUT. Okay, so let me download the configuration file for 12X7. Okay, here we can see the pin, the name for the pin for each pin are entered, and the connection are selected. And here we can type in some note for this tube. Maybe, for example, this maybe we can say, okay, this configuration file is designed for a special brand of 12A7, and the type this entry box we put in the description of what the DUT is. Okay, so that's basically the configuration for the user, and it's not tied to the hardware. And after entering all this information, we can save the TÜV configuration file to a different name. We can always save it and load it for to edit later. Okay, so that's pretty much what I'm going to cover in this video clip. And in the following video clips, we'll go through each type of vacuum tubes and talk about how to design, how to set these parameters to under different tabs. Okay, thanks for watching. I'll see you next time.